Okay, yesterday we talked about solving systems of linear equations by graphing. And we alluded to remembering how to do substitution and elimination. And while we covered it last year, this is just all of it in one spot. So we'll kind of touch base and make sure we understand what's going on. So let's remember how to graph. I'm going to start with this one because the y is already alone. Where's my y-intercept? -2, and then my slope is down 1 over 4?
Up 1 over 4.
Or up 1 over 4?
Yeah.
I'll do that too. And then I connect the dots.
Dude, I feel like not see.
Yeah, those are kind of blurry, little tiny. So there is our bottom line.
Do we have to do that on both sides?
Mine's really not straight.
That's okay, I cheated.
My phone is a ruler, so.
Now on this one, I need to get the y alone. So I'm going to add the 2x to the other
Wait,
side.
for the second point, is it just up 1, right 4?
Yep,
Oh.
yep.
Why is it crooked? What the heck? This is John.
So up 7, 2, 4, 6, 7. And then up 2 over 1. Down 2 over 1.
Oh, is it over 4, down 1?
Rise 1, run 4.
I don't know that's why it's weird. Alright, I get it.
Okay, now the reason I used my ruler is because it mattered when we're graphing it by hand, and I know you guys don't have the advantage of that, but you can look at mine.
Oh, yeah.
What do you notice? It crosses right here.
Yep.
So our solution is what? That is -1, 2, 3, 4. -4, -1.
Yep.
All right.
Good job.
We got good at that yesterday. Yeah,
I ate that up.
we did. So now let's remember how to do substitution and elimination. Substitution is where we get the x or the y alone and we plug it into the other one. Now I look at this. Is one of the variables in either equation easier to solve for than the other ones? Wouldn't it be easy to get that x alone? All we have to do is what? Move 3y to the other side?
Mm-hmm.
Okay, so I'm going to rewrite this equation, and I'm going to call it x equals 1 plus 3y. So I don't need to think about that one anymore because I just rewrote it.
Oh.
What's the question? Because I would love to answer it.
Why did you do that?
Why did I do that? Can I show you next instead of telling you?
Yeah.
Okay. The reason we're doing that is because now I know x equals 1 plus 3y. So if I look at my other equation, what can I replace that x with if x equals 1 plus 3y?
1 plus 3y.
Yeah. So what we're trying to do is get our equations to only have one variable instead of two. We can't solve if there are two variables there. So watch and see what happens. So I'm going to rewrite this top one. 3 times, what did we say x was?
1 plus 3y.
1 plus 3y. And then I have minus 5y equals 11. Is that an equation that we can just combine like terms, follow order of operations, and solve for y? Yeah.
Yep.
So let's distribute here. We would have 3 plus 9y minus 5y equals 11. I'm going to do two steps at once right now. I'm going to take away my 3, but I'm also going to combine those while I'm at it, okay? So I would have a 4y equals 8. So y equals 2. Now if I look, over here on this one, my answer was a point. It was an x and a y. I found the y, so what do I need to do? Substitute it back in up there to get the x value. So let's see. I've got this x equals 1 plus 3. What is y? 2. So x is 1 plus 6. So x is 7. When you type this in, make sure you have your x value first and your y value second. X and then y. Questions on that? Okay, so substitute is where we get a variable alone and we plug it back in. In fact, I'm going to write right here that that's what we used. We used substitution.
When does this term end?
We just had midterm.
So
So another 4 weeks.
October 16th.
Yeah, somewhere in there. Okay, on this one, we are going to use elimination. Using add and subtract. And I'll show you what I mean. Elimination is when we line up our x's, our y's, our equals, and our constants, and we add our equations vertically. And we want something to disappear. So 2y plus 2y doesn't equal 0. But what if it was 2y minus 2y? Would that equal 0?
Yeah.
So I need to change, if I want that to be a minus, I have to flip the signs on all of them. And what if they had been a minus? It would make it a positive, right? I'm just changing all of the signs. So now let's add vertically. 5x minus 9x is negative 4x. Those cancel. 2 minus 2 is 0. Equals 6 minus 22 is a, yes, negative 16. Divide by 4, divide by negative 4, so x is 4. And then to solve for the y, pick whichever one makes you happier. The top one makes me happier, so that's the one I'm going to use. So we got to solve for y, so we're going to go 5 times, what's our x value? 4 plus 2y equals 6. 20 plus 2y equals 6. Take away 20, take away 20. 2y is negative 14. So y is negative 7. So our x and our y. Does this feel kind of familiar from last year-ish? You guys are going to need to spend some time and ask me questions then. What did you like, substitution or elimination better? I kind of like elimination too, unless substitution is like set up for me and it's easy.
It's a little bit easier.
Yeah, it just feels cleaner a little bit, doesn't it?
It doesn't look as messy.
Yeah. This one, however, if I want to use elimination, so let me put elimination again. This one we're going to have to use multiplication.
I like how you write your E's.
Thanks. My crazy backwards threes.
I should.
How important was it to have opposite numbers over here?
Very.
That's what made it happen, right? That's where we get the elimination.
Oh, there's not.
What if there's not? This is what I do.
No solution.
Not true. What do 3 and 5 go into? 15. What if 4 and 2 go into?
8.
Lower.
4.
4. One of them is already a 4.
Oh.
So that's how I decide that I'm going to eliminate y's.
Okay.
Okay, I look and I figure out the least common multiple, and I'm going to go with the easy. I would have to multiply this to get 15. I would have to multiply this to get 15. But on this one, I'm only going to have to multiply one equation, right? I've got a positive 4 up there, so what do we need this one to be to get a 0?
4.
Negative 4, right? Negative 4. So what do I need to multiply this equation by to have a negative 4 right there? Negative 2. So I need to multiply this equation by -2. So I would have, let's see, -10x minus 4y, and all the way across. Sometimes it's really easy to forget that we've also got to times that constant. In fact, I could write it like this. Multiply both sides by -2. So that equals 8. Now, for my sanity, you guys, I am going to rewrite this equation right on top of it, because when I'm working with elimination, I like to have them stacked together. Are my y's going to cancel?
Yes.
So then I know I set it up right.
Yep.
I've got 3 minus 10 is
-7.
-7x. I've got 6 and 8 is,
-2.
they're both positive.
2.
They're both positive, so 6 plus 8.
Oh.
Yeah, sneaky, huh?
And I had that way wrong.
So x is 14 divided by -7 is -2. Yep.
-2. Okay.
Now to solve for the y, do you guys like the top equation better or the bottom?
Top.
Okay.
Top is more comforting.
So I know, and it's sort of whatever one gives you more warm fuzzies, kind of like the blanket there. So whatever I say.
Yeah, this
3
one is
times -2 plus 4y equals 6. I've got -6 plus 4y equals 6. Add 6. So 4y equals 12. Divide by 4, and y equals
This is being messy.
3. There was a lot going on there, right?
Yeah, so it's -2 and 3?
Yep. Oh, I didn't write that down. I'm glad you reminded me to write it as an ordered pair. So I've got -2 and 3. That is perfect.